Ever wondered how the universe really works? Or what secrets history left behind? You are about to find out. Right now, somewhere in the universe, a star is being born.
And somewhere else, one is dying in a blinding explosion brighter than a billion suns.
This is the story of every star that has ever existed, including our own Sunday. From birth, to fire, to death. It begins in darkness.
A vast cloud of hydrogen gas and dust, called a nebula, drifts through space.
These clouds are enormous. A single stellar nursery can span hundreds of light years across. For millions of years, nothing happens.
Then, something disturbs the cloud. A nearby supernova shockwave, or the gravitational tug of a passing star.
And gravity begins to win. Pockets of gas collapse inward. As matter falls toward the center, it heats up. Pressure builds.
A swirling disk of material forms, and at the center, a glowing core emerges.
This is a protostar. Not yet a star, but getting there. The temperature at its core is climbing. 1 million degrees. 5 million. 8 million.
At 10 million degrees Celsius, something extraordinary happens. Hydrogen atoms are slammed together with so much force that they fuse into helium.
This is nuclear fusion.
For hydrogen nuclei become one helium nucleus, and a tiny amount of mass is converted into pure energy.
E equals mc squared in action. The energy pushes outward. Gravity pulls inward. And a perfect balance is struck. A star is born.
This is the main sequence, the longest chapter of a star's life. Our Sun has been burning hydrogen for 4.6 billion years, and it has about 5 billion more to go. But not all stars burn at the same pace. Small red dwarfs, the most common stars in the galaxy, burn so slowly they can last trillions of years. Blue supergiants, on the other hand, burn through their fuel in just a few million years.
The rule is simple. The bigger the star, the faster it dies.
Eventually, the hydrogen in the core runs out. Without fuel, the core contracts under its own gravity and heats up.
The outer layers of the star respond by expanding enormously.
The star swells to 100 times its original size, and its surface cools to a deep red.
It has become a red giant. When our Sun reaches this stage, it will engulf Mercury, Venus, and possibly Earth.
For stars like our Sun, this is the beginning of the end. The outer layers drift away gently, forming a glowing shell called a planetary nebula.
One of the most beautiful objects in the universe. What remains at the center is the exposed core, a white dwarf.
Roughly the size of Earth, but with the mass of an entire star packed inside. A teaspoon of white dwarf material would weigh about 15 tons.
Over trillions of years, it slowly fades to black. But massive stars?
They have a far more violent fate.
Inside a dying supergiant, the core becomes an onion of elements.
Layer after layer of fusion, hydrogen, then helium, carbon, oxygen, silicon, and finally, at the very center, iron.
Iron is the dead end. Fusing iron does not release energy. It absorbs it.
The moment the core turns to iron, the star has written its own death sentence.
In less than 1 second, the iron core collapses.
A sphere the size of Earth crushes down to just 20 kilometers across. The infalling material rebounds off the ultradense core and explodes outward in a supernova.
For a few weeks, this single dying star outshines its entire galaxy.
Billions of stars, and one death burns brighter than all of them combined. The explosion scatters heavy elements across space: gold, platinum, uranium, the calcium in your bones, the iron in your blood. All forged in this moment.
What is left behind depends on mass.
If the core is under about 3 solar masses, it becomes a neutron star. An object so dense that a teaspoon would weigh 1 billion tons.
Some neutron stars spin hundreds of times per second, blasting beams of radiation into space. We call these pulsars.
But if the core is more massive, not even neutrons can resist the crush of gravity.
The core collapses into a point of infinite density. A black hole.
Where space and time themselves break down.
But here is the most beautiful part.
The debris from a supernova does not just vanish. It spreads out, mixes with surrounding gas, and forms a new nebula. And inside that nebula, gravity begins pulling matter together again.
New stars ignite. New planets form. Every atom in your body was forged inside a star that died so that you could live.
We are, quite literally, made of stardust.
One last thing.
The red supergiant Betelgeuse, the bright shoulder of Orion, could go supernova any time in the next 100,000 years.
When it does, it will be visible in broad daylight for weeks. You might just get to witness the death of a star with your own eyes. And that is the life and death of a star.
If this blew your mind, subscribe and hit the bell so you don't miss our next deep dive.
See you in the next one. Every week. See you in the next one.